After more than a month of testing, I finally completed our full AMD X870/X870E motherboard roundup, and with in-depth testing of 20 models, there is a lot to go over. But before we do, please note the only boards not featured in this roundup include the MSI Meg X870E Godlike, because apparently that board's not ready yet, as in MSI hasn't actually released it, and the same also applies to Gigabyte's X870 Gaming Wi-Fi 6. Then the only other missing board is the Asus ROG Strix X870-F Gaming Wi-Fi, which for reasons unknown, Asus were unable to supply and I couldn't get my hands on one in time. So not wanting to delay this content, I've gone ahead without those three models. So let's get into it. So let's get one of the more depressing statistics out of the way. The Asrock X870 ProArt Wi-Fi is the cheapest X870 motherboard on the market right now, and it costs $200 US for the non-Wi-Fi model, or $210 US for the Wi-Fi version. So if you're okay with that, let's continue. For $210 US, you're at least getting a highly robust 1480 amp power stage VRM, Wi-Fi 7, and 2.5 gigabit LAN. There's 2 PCIe x 16 slots, 3 M.2 ports, 4 SATA ports, and a fairly limited range of USB support. Over on the I/O panel, there are a dozen USB ports, which sounds awesome. That is until you realize half of them are USB 2.0 ports, which, in my opinion, for a board priced at or over $200 US is very underwhelming. Now, there are meant to be 4 USB 3.2 Gen 1 ports, however, one of them appears to be a USB 2.0 port in disguise, and if not, there's something wrong with our board, as I was unable to get this port to average better than 43 megabytes per second in our test, and I tried multiple things to get it to work, all of which failed. So this is either a BIOS level bug, a defect with this model, or a problem with our individual sample. As for general performance, the X870 ProArt Wi-Fi was fine, peaking at just 53 degrees for the VRM. It sustained an average clock frequency of 5,100 MHz and scored 2,303 points, which is excellent. ECC memory support worked flawlessly, but we were unable to boot with our DDR5 8000 memory with the 8000 Expo profile loaded, and in order to stabilize the system, we had to reduce the memory speed to 7400. Overall, the X870 ProArt Wi-Fi gets the award for the cheapest X870 motherboard, but I hope other entry-level models are a bit more exciting. The Asrock X870 Riptide Wi-Fi is a $260 US model packing 1480 amp power stages for the V-Core, 2 full-length PCIe x 16 slots. The primary is PCIe 5.0 compliant and wide for x 16 bandwidth, while the second slot is 4.0 compliant with just x4 bandwidth. There's a single PCIe 5.0 M.2 with 2 PCIe 4.0 M.2s, Wi-Fi 7 support, and 2.5 gigabit LAN. Now for USB, there are 10 3.2 ports in total, 8 2.0 ports, and of course 2 4.0 ports. Over on the rear I/O, there are 11 ports in total, though not all of them are high speed. There are 4 USB 2.0s, which limit you to around 40 megabytes per second. Then there are 3 USB 3.2 Gen 1 ports with a throughput of about 440 megabytes per second, 2 USB 3.2 ports capable of 940 megabytes per second, and 2 USB 4.0 ports. It's a decent configuration, but also a bit underwhelming for a board priced at $260 US. Now here's a look at the X870 Riptide Wi-Fi scorecard. It sustained an average clock frequency of 4,990 MHz, and this resulted in a Cinebench score of 2,239 points. And across the EPS 12-volt rails, the CPU consumed 226 watts, and despite this, the board's VRM peaked at just 54 degrees. Sadly though, using the latest BIOS revision, there's no onboard reporting for VRM temperatures, but hopefully Asrock can add this in for their users in a future BIOS revision. As for ECC memory support, you get full support on the Riptide, but unfortunately I wasn't able to get our G.Skill DDR5 8000 Expo memory kit stable at 8000, as it would fail our stress test inside of an hour. In fact, the maximum stable frequency to pass our hour-long stress test was 7600. Overall, we found no real issues with the Riptide. It tested really well despite the unstable DDR5 8000 support, though this is common amongst X870/X870E motherboards, and really you are much better off pairing your Zen 5 or Zen 4 processor with low latency DDR5 6000 memory. Now, typically speaking, Asrock's Steel Legend series offers great value, so I'm keen to see what the X870 Steel Legend has for us at $260 US. Actually, the X870 Steel Legend is the same motherboard as the X870 Riptide Wi-Fi, which helps explain the price. Basically, the Steel Legend is a white-silver themed version of the Riptide, so all of the board features are the same, as is the I/O panel configuration. So there's not too much point going over all of this again. That said, the USB 3.2 Gen 2 ports tested a little bit better on the Steel Legend, which is odd, as I didn't expect they'd be configured differently, but maybe they are. The operating behavior of the Steel Legend was very similar to that of the Riptide. The VRM temperature only deviated by a degree, and the overall performance was near enough to identical. Memory support was also the same, so unlike the ProArt, the Steel Legend did boot successfully with DDR5 8000 Expo loaded, but it would fail our stress test inside of an hour, making 7600 the fastest memory speed we could achieve with our kit. So like the Riptide, we found the Steel Legend to be a perfectly fine motherboard, and I quite like the design of this model. The Asrock X870E Nova Wi-Fi costs $330 US, and for that price you get a massive 20 110 amp power stages for the V-Core, and this is of course an X870E motherboard, so 2 chipsets for better connectivity. This means there's now 5 M.2 slots in total, one which supports PCIe 5.0, and the wide networking has been upgraded to 5 gigabit. As for USB support, you'll still find 2 USB 2.0 ports on the I/O panel, but there are loads of high-speed ports here as well. There are just 3 USB 3.2 Gen 1 ports with 5 Gen 2 ports, and of course you do get those 2 USB 4 ports as well, so you don't have to go too far looking for a high-speed USB port. As you'd expect, VRM thermal performance was excellent, peaking at just 50 degrees, and during our test we saw an average clock frequency of 5080 MHz, with 214 watts drawn across the 12-volt rails, and all of this allowed for a score of 2,268 points. You're also getting full ECC memory support with the Nova, but again our DDR5 8000 Expo kit failed to boot, limiting us to a maximum stable memory speed of 7400. Overall, the Nova is a solid board, and while $330 US is certainly a lot of money for a motherboard, it is one of the better value X870 models. Now, there are 2 versions of the X870E Taichi, the standard Taichi, which costs $430 US, and then the Taichi Lite, a sort of cut down version that costs just $380 US. But it's not cut down in terms of board features or VRM design, rather it does away with the flashy stuff. Quite literally, stuff like RGB lighting is gone, the fancy heatsinks are gone, and so too are some of the toolless features, but other than that, they are technically the same product. Around at the I/O panel, you'll find the exact same connectivity, and in fact, it's really the same I/O as the $330 Nova. So disappointingly, this flagship board still includes stuff like USB 2.0 ports in the I/O, along with a few USB 3.2 Gen 1 ports. Still, there are 5 USB 3.2 Gen 2 ports, and of course those USB 4 ports, so there are still plenty of high-speed USB ports, but for over $400 US, the Taichi is a little bit lackluster in that regard. The board did test fine though, with a peak VRM temperature of 52 degrees, and interestingly, onboard reporting was enabled for this model and working very well, as Hardware Info reported a VRM temperature of 51 degrees, which is very close to what we found using our K-type thermocouples. And again, while you are getting proper ECC support, our DDR5 8000 Expo kit completely failed. It just wouldn't even boot with the 8000 profile loaded, and for stability we had to drop it all the way down to 7400. Overall, the Taichi and Taichi Lite, like the Nova, are solid boards, but for an extra $50 over the Nova, the Taichi Lite doesn't really offer that much. In fact, you could argue the Nova is the better board, offering additional board features such as easy release, RGB lighting, if you're into that, an additional PCIe slot, and an additional M.2 slot. The most affordable Asus X870 motherboard is the $250 Prime X870-P Wi-Fi, And it's an interesting board because it's one of the few to include 4 PCIe times 16 slots. And although just the primary slot is wired for times 16 bandwidth with the rest limited to times 1 bandwidth, that's still a unique feature. As for the rest of the board, you're still getting stuff like 14 80-amp power stages for the V-Core, 4 M.2 slots, Wi-Fi 7 and 2.5 gigabit LAN, though the USB support is rather limited. That's because the board supports just 14 USB ports in total, and 10 of them can be found at the rear I/O panel, and just a few of them are capable of USB 3.2 Gen 2 speeds or better. 4 of them in fact are USB 2.0 ports, with another 3 limited to USB 3.2 Gen 1 speeds. There's a single Gen 2 port, and of course 2 USB 4 ports, so it's a decent configuration, but for $250 US, you'd probably expect a bit more USB 3.2 Gen 2 there. As for the rest of the board, it is very good. The VRM peaked at just 55 degrees, though there is no onboard reporting, and this is a common theme for Asus boards. Interestingly, while there is no ECC support, the ECC memory still booted and passed our stress testing, but the ECC functionality is disabled. Our DDR5 8000 memory passed validation, though it only worked at 8000. Any speed beyond that was unstable and would crash within our 1 hour stress test. So as I said, it's an interesting entry-level motherboard from Asus with a unique PCIe configuration, but other than that it is very basic, especially when you consider the price. Asus clearly isn't a fan of offering sub $300 X870 motherboards because the next cheapest model is the tough gaming X870 Plus Wi-Fi, and it costs an eye-watering $310 US. But when compared to the X870-P, you're not really getting much more for your extra $60 US. You're still getting 4 M.2 slots, though there are now 2 that are PCIe 5.0 compliant. Networking support goes unchanged. The VRM gets 2 extra power stages, which isn't really necessary, though USB support has been improved. The number of USB ports on the I/O panel remain the same at 10, but whereas the X870-P featured 4 USB 2 ports, the Tough Gaming includes just a single old slow USB port. Instead, it includes an extra USB 3.2 Gen 1 port and 2 extra Gen 2 ports, so a much better USB configuration overall. Now, despite featuring 2 additional power stages, we still saw a peak VRM hotspot temperature of 55 degrees, which is still very good. Overall performance was much the same, but when it comes to memory support, the Tough Gaming failed our DDR5 8000 stress test, and in fact, could only pass once we dropped the memory speed as low as 7400. Boot time performance was excellent at 17 seconds, and audio performance was similar to that of the X870-P. So the Tough Gaming X870 Plus Wi-Fi is a bit of a mixed bag, but the biggest issue here is of course the price. At $310 US, it is only slightly cheaper than Asrock's X870E Nova Wi-Fi, which is by most accounts a much better product. With the Asus ROG Strix X870-A gaming Wi-Fi, we're already at Taichi Lite money, $370 US for this one, so you'd expect something pretty amazing, I would have thought. That said, this is still an X870 board, so just a single chipset, but you do get 4 M.2 slots, 2 of which are PCIe 5.0 compliant, and there's support for up to 20 USB ports. Speaking of which, over on the rear I/O panel, you'll find a dozen USB ports, the slowest of which is USB 3.2 Gen 1, so none of those stinky USB 2.0 ports here. There are 4 USB 3.2 Gen 1 ports, 6 USB 3.2 Gen 2 ports, and those 2 USB 4 ports, so a great USB configuration. As for the rest of the board, the testing was fairly typical. The VRM peaked at 58 degrees, and there is no onboard reporting. Power consumption was a little on the high side, but so was performance with a score of 2,305 points. The ECC memory did boot, but ECC support was non-existent. DDR5 8000 did fail to boot, and would only boot and complete our stress test once slightly reduced to 7800. So that's what you get from Asus for $370 in their X870 range, now into something even more expensive. And that more expensive board would be the $480 US Asus ProArt X870E Creator Wi-Fi, which can split the CPU's PCIe x 16 lanes between the primary and secondary PCIe x 16 slots for a x8/x8 configuration. There's also a third PCIe x 16 slot wired for up to x4 bandwidth. You're also getting 10 gigabit networking support, which can be very handy for creators and professionals alike. This board is also a beast when it comes to USB support, providing 7 USB 3.2 Gen 2 ports with no Gen 1 ports, though there is a single USB 2.0 port which is used for the BIOS flashback feature. There's also a 20 gigabits per second Type-C, along with two 40 gigabits per second Type-C ports which provide that USB 4 support. The rest of the board tested fairly well, overall performance was good, and we saw a peak hotspot temperature of just 53 degrees. Sadly, however, this Creator motherboard lacks ECC memory support and was also unable to survive our DDR5 8000 stress test, only passing at 7600. Overall, the ProArt X870E Creator Wi-Fi is a unique X870 motherboard thanks to the PCIe configuration and 10 gigabit networking support. The Asus ROG Strix X870E gaming Wi-Fi is getting to the pointy end of the Asus X870 lineup at $500 US. And you have to wonder how much more expensive these boards can get, and of course we'll answer that in a moment. For now though, we have the X870E-E, a name that's not confusing at all. Around at the I/O panel, there's more USB ports than most will know what to do with, so just enough for me and my countless devices. Not only are there 13 ports in total, but not one of them is limited to USB 2.0 or even USB 3.2 Gen 1. They're all Gen 2 or better, meaning they're good for around 1 gigabytes per second or better. Lovely stuff. The board also tested exceptionally well. The VRM peaked at just 60 degrees, and anything under 80 degrees is perfectly fine, as in, as cool as a cucumber. In typical Asus fashion, there's no ECC support, but this time DDR5 8000 did actually work, and 8000 was as far as we could go without compromising stability. Overall, the ROG Strix X870E gaming Wi-Fi is certainly a feature-rich board, but is it worth $500 US? Hard to say, also hard to imagine spending that much money on a desktop motherboard, but people clearly do, or they'd stop making them. Now, the tip of the spear is the $700. Yep, $700 ROG Crosshair X870E Hero, and for an extra $200 over the already alarmingly expensive ROG Strix X870E gaming Wi-Fi, I'm not really sure why the Hero costs so much more. Both pack the same 18 110 power stage V-core, which is beyond overkill. There's 2 PCIe x 16 slots, 3 PCIe 5.0 M.2s with 2 PCIe 4.0 M.2s, 4 SATA ports, loads of USB ports, Wi-Fi 7, but in addition to the 5 gigabit LAN, the Hero also gets a second 2.5 gigabit LAN port. The rear I/O configuration is slightly downgraded for the Hero. There's 3 less ports and overall connectivity is a bit slower. The Hero did test very well though, and not only passed with DDR5 8000 Expo, but with the locked stock timings passed an hour-long stress test right up to DDR5 8300. The key advantage of the Hero seems to be the PCIe configuration, which sees the primary and secondary ports support PCIe 5.0, and they can run in a x8x8 mode. Though be aware when the second and third M.2 slots are in use, the secondary PCIe slot is disabled completely, as the AM5 platform simply doesn't have enough lanes. Overall though, the Hero seems to be more about bragging rights, as it doesn't do too much to justify the huge price premium over the already expensive ROG Strix X870E gaming Wi-Fi. Finally, the last Asus X870 board is the ROG Strix X870i gaming Wi-Fi, the only mini ITX X870 board to be released at this point in time, and it costs $450 US. So you're getting a bit rolled on the price there, probably due to the fact that this is a mini ITX board and it has limited competition, or as I said, there's no competition right now. The USB support's pretty basic considering the price, just 10 ports on the I/O panel and 3 of them are USB 2.0. Thankfully though, the rest are USB 3.2 Gen 2 or better, so that's still 7 high-speed ports to pick from. This little board did test well. The 10 110 amp power stages peaked at just 52 degrees, and the board passed our DDR5 8000 Expo test. I didn't end up testing audio for this board as the ROG Strix Hive 2 only has a single 3.5mm audio mic port, and I didn't want to try and loop this back through the case header as the results probably wouldn't be that accurate. Overall, I can confidently say that the Asus ROG Strix X870i gaming Wi-Fi is very small and very expensive. Okay, time to check out the Gigabyte range, and we'll start with the cheapest model, the X870 Eagle Wi-Fi 7, which costs $220 US. And despite being an entry-level board, you're still getting 14 60-amp power stages just for the V-Core, along with the expected Wi-Fi 7 and 2.5 gigabit LAN support. In terms of USB, it's not that dissimilar to the Asrock ProArt, though we did find that all ports performed as expected. There's also a USB 3.2 Gen 2 port, whereas the Asrock board only featured a Gen 1 port. Asrock also lacks the Quick Connect feature for the Wi-Fi antenna, and this is a nice addition to the Eagle. The Eagle did run quite a bit hotter than most of the X870 motherboards we've tested, but even at 76 degrees, it's still relatively cool for a VRM hotspot temperature, so no real issues there. That said, we did only see an average clock frequency of 4,780 MHz in our test, which is the lowest frequency of any board that we tested. And this also meant the lowest score of 2,216 points, though that only made it 4% slower than the fastest board tested, so really not a big difference there. DDR5 8000 also failed our stress test, with 7600 being the highest speed we could pass the test with, so that's a bit disappointing, but not that uncommon, as I've said, for these X870/X870E motherboards. Overall, the X870 Eagle Wi-Fi 7 is a very basic board, which is typically what you expect from an entry-level product, but I think as far as AM5 motherboards go, it is very basic at $220 US. The Gigabyte X870 Gaming X Wi-Fi 7 comes in at $250 US, so the same price as the Asus Prime X870-P Wi-Fi and slightly cheaper than the Asrock X870 Riptide Wi-Fi and X870 Steel Legend. Gigabyte has gone with 60-amp power stages, but there are 16 of them. They've included one less PCIe x16 slot than Asus, but one more than Asrock. There's 3 M.2s, so the same as the Asrock board, but one less than Asus. And USB support is slightly better than Asus, but slightly worse than Asrock. Around at the rear I/O, there are 10 USB ports, so the same as the Asus Prime X870-P Wi-Fi, and the general configuration is much the same, so they're pretty similar in that regard. When it comes to performance, the Gaming X Wi-Fi 7 is just fine. The average operating frequency was good, the overall score was good, and the memory performance was great, passing our stress test using DDR5 8000, though it does lack ECC support. Overall, a decent motherboard relative to the other options, but again, for $250 US, it won't exactly blow your socks off. Now, there are two versions of the Gigabyte X870 Aorus Elite Wi-Fi 7, the Ice version, which we have on hand for testing, and then the standard version, which is black and doesn't have Ice in the name. The Ice version indicates that this is a white version of the board, and other than the color, everything else is exactly the same, and both versions cost $275 US right now. When compared to the Gaming X, you're getting the same 16 60-amp power stage V-Core, but the M.2 support has been upgraded to 4 slots, 3 of which are PCIe 5.0 compliant. Other than that though, the rest of the features are very similar. Around at the I/O panel, there are an additional 2 USB ports, 2 of which are USB 3.2 Gen 2, along with an additional USB 3.2 Gen 1 port. So there are a few upgrades here for that extra $25. Personally though, I prefer the look of the Aorus Elite, and I do think it's worth the small premium. I also think it's better value than the more expensive Asus Tough Gaming X870-Plus Wi-Fi. The X870 Aorus Elite also tested well, averaging 5,040 MHz in our stress test for a score of 2,315 points, with a peak VRM hotspot temperature of 65 degrees. Sadly though, it does lack ECC memory support, and DDR5 8000 failed, forcing us to lower the memory speed to 7600 in order to pass the hour-long stress test. Overall, the X870 Aorus Elite Wi-Fi 7 Ice performed well, and I particularly like the look of this Ice version. For those willing to spend a bit more, you can get the Gigabyte X870E Aorus Pro, and this model gets upgraded to 80-amp power stages, and there's still 16 of them. Other than that, they're again very similar. Around at the I/O panel, the Aorus Pro drops 2 of the USB 2.0 ports and adds an additional USB 3.2 Gen 2 port, but that's the extent of the changes here. In terms of performance, the Aorus Pro is again very similar to the Aorus Elite. The VRM ran quite a bit cooler at 54 degrees thanks to those upgraded power stages, but really, the Elite was already overkill there. The Aorus Pro did fail our memory test multiple times in under an hour, so either the Elite got lucky or it's slightly better in that regard. Overall, for the extra $20 US, you're not really getting much with the Aorus Pro, certainly nothing I think you'd need over the Elite. Finally, we have the Gigabyte X870E Aorus Master, which costs $500 US, so the same price as the Asus ROG Strix X870E-E gaming Wi-Fi, and when compared to the competition, it's very similar. There are 3 PCIe 5.0 M.2 slots, though just 4 M.2s in total, whereas Asus offers 5. That said, there are 3 PCIe x 16 slots, whereas the Asus board includes just 2, and both boards include 5 gigabit LAN. As for the USB configuration on the I/O panel, the Master is almost identical to the Pro, it just includes an additional USB 3.2 Gen 2 port, and this means it's not nearly as impressive as the ROG Strix X870E-E gaming Wi-Fi, which offers more than twice as many USB 3.2 Gen 2 ports. In terms of performance, the Aorus Master was excellent, though I was a little surprised to find the VRM peaking at 62 degrees, but even so, this is well within safe limits, and could best be described as an overkill result. The CPU also averaged 5022 MHz for a score of 2,289 points. Oddly, this is the only Gigabyte X870 motherboard to support ECC memory, and it also not only passed the DDR5 8000 Expo test, but with lock timings was able to push the memory to 8200 and still pass an hour-long stress test. So there is no denying the Aorus Master is an excellent motherboard, despite being a bit of a letdown when it came to USB support. Now, on to MSI, who has just 3 X870/X870E motherboards, as the godlike still isn't ready. And I'm really not sure how much this board counts anyway. So a very limited lineup from MSI for AMD's latest platform. There's clearly something very wrong with the MSI/AMD relationship. Anyway, the Pro X870-P Wi-Fi is MSI's most entry-level offering, and it costs $230 US, pricing it to compete with the Gigabyte X870 Eagle Wi-Fi 7, Asus Prime X870-P Wi-Fi, and Asrock X870 ProRS Wi-Fi. The Pro X870-P Wi-Fi is the only board in this price range to offer 5 gigabit LAN. It also packs 4 PCIe x 16 slots, 3 M.2 slots, 4 SATA ports, and a reasonable degree of USB support. Around at the rear I/O panel, there are 10 USB ports in total, 4 of which are USB 2.0 ports. Still, there are 2 USB 3.2 Gen 1 ports and 2 USB 3.2 Gen 2 ports, along with a 20 gigabits per second USB 3.2 port. Oddly, however, there's just a single USB 4 port, making this the only X870 motherboard I've come across not to offer 2 USB 4 ports. And this is strange because the official AMD X870 spec calls for 2 USB 4 ports, or at least that's how we've interpreted the information. Whatever the case though, this board has just a single port, so that kind of sucks. In terms of performance, the Pro X870-P Wi-Fi worked well enough, general performance was excellent, VRM thermals were good, and it was stable with DDR5 8000 memory, turned all the way up to 8100. Overall, the Pro X870-P Wi-Fi is a decent motherboard, and depending on what features you prioritize, it may or may not be better than the other entry-level boards. The MSI Mag X870 Tomahawk Wi-Fi is priced at $290 US, which is a bit of a unique price point. For example, it's just $15 more than the Gigabyte X870 Aorus Elite Wi-Fi 7, but $20 less than the Asus Tough Gaming X870-Plus Wi-Fi, and then $30 more than the Asrock X870 Steel Legend. I wasn't a big fan of the Tough Gaming, so let's compare it with the Gigabyte X870 Aorus Elite Wi-Fi 7. Specs-wise, they're very similar. Both have massive VRMs, 14 80-amp power stages for the Tomahawk. The Aorus Elite gets an extra PCIe 5.0 M.2, but they both have 4 M.2 slots in total. Both offer 4 SATA ports, 2 USB 4 ports, and Wi-Fi 7, but the 2.5 gigabit LAN of the Gigabyte board has been upgraded to 5 gigabit on the Tomahawk. Around the I/O panel, we find very similar USB configurations. The Tomahawk swaps out one of the USB 3.2 Gen 1 ports found on the Aorus Elite for a Gen 2 port. So there are the same number of ports overall, just a small alteration to how they're configured. As for performance, the Tomahawk did very well, somehow averaging a clock speed of 5,110 MHz for a score of 2,306 points, which is one of the highest scores we've seen across our testing. The VRM peaked at just 54 degrees, and MSI provided an onboard probe, which Hardware Info was able to read, and it reported the same peak temperature as our K-type probes. MSI's boards don't include ECC memory, and the kit we used isn't supported at all, as in the system won't even post. That said, DDR5 8000 did work, and we could even run up to 8100. Overall, the Tomahawk is a decent motherboard, and depending on what you're after, it might represent the best value at this price point. Finally, we have the MSI MPG X870E Carbon Wi-Fi, which is a massive step up in terms of price at $490 US, which places it in direct competition with the Gigabyte X870E Aorus Master and Asus ROG Strix X870E gaming Wi-Fi, while it fetches a $60 US premium over the Asrock X870E Taichi. In terms of specs, these boards are all fairly similar, but if you care about USB support, it has to be the Carbon Wi-Fi or ROG Strix X870E gaming Wi-Fi. Both of these boards offer loads of USB 3.2 Gen 2 ports on the I/O panel, and 10 gigabits per second is the slowest USB port you'll find at the rear of these boards. I really like the buttons for the BIOS flashback, clear CMOS, and the smart button on the MSI board, and that additional wide LAN connection is also quite handy. The Carbon also tested well, sustaining a clock frequency of 5,050 MHz, and this allowed it to produce a score of 2,281 points, and we also saw a peak VRM temperature of 58 degrees. It did fail the ECC memory test, but DDR5 8000 Expo worked, and we could even push it up to 8100. Overall, the Carbon is one of the best flagship X870E motherboards, and while I think $500 is too much to spend on an AM5 motherboard, if you're going to, this is a good choice. So you've already seen how each of these boards perform, but here's a quick look at the data in a single graph. And just quickly, here are some of the notes for the testing. The case used is the Antec Flux Pro, and for recording temperatures, I'm using a digital thermometer with K-type thermocouples, and I'll be reporting the peak PCB temperature. Finally, I'm not reporting delta T over ambient, instead I maintain a room temperature of 21 degrees, and to ensure a consistent ambient temperature, a thermocouple is positioned next to the test system. As for the stress test, I'm using the Ryzen 9 9950X, and for load Cinebench 2024, which was looped for an hour, at which point I'm reporting the maximum PCB temperature, again recorded using K-type thermocouples. As you can see, most of the boards performed in the 50 to 65 degree range, which is very cool. And although the Gigabyte X870 Eagle looks particularly bad at 76 degrees, that's actually still quite a cool operating temperature and is far from being an issue. That said though, the Eagle did sustain the lowest average clock speed during our hour-long stress test at 4,780 MHz, while the average result across all of the boards tested was 4,988 MHz, so we're 4% below the average with the Eagle, and 6% slower than the best recorded result. Most of the boards though were within a 2% variance of one another, which is pretty typical. As for actual performance, the range was even tighter, with the best and worst boards only separated by a 4.5% margin, and again, most were within a 2% margin, so there are no real performance concerns here. For measuring boot time performance, we're simply loading the DDR5 6000 CL30 Expo profile in the BIOS, and leaving everything else stock. So this should represent the kind of performance you'll see with a clean install of Windows 11. The results are based on a 3-run average and appear somewhat random, though we are only talking about a 6-second deviation between the fastest and slowest boot times. Now here's a comparison of the maximum stable DDR5 frequency of each board using the latest available BIOS revisions at the time of testing, and all boards were using AGESA 1.2.0.2. Of the 20 boards tested, just over half of them were unstable using DDR5 8000 memory, And I suspect with a longer, more diverse range of stress tests, some of the boards that have passed here might end up failing. And granted, I am only using a single G-Skill kit, but I know this kit is stable at 8000. So either some of these boards simply can't do it, or they require more work at the BIOS level. Back when AMD first rolled out the 600 series chipsets, we found a number of boards that weren't stable using DDR5 6000 memory, but they did eventually get fixed with updated BIOS revisions. So perhaps this will be the case with these 800 series boards and DDR5 8000. In the meantime though, this isn't a particularly good look for AMD, given they've officially said, and I quote, DDR5 8000 is ideal for an AMD X870E motherboard. And I'm sure they're not trying to sell you an expensive X870E motherboard though, that wouldn't be it. As for the audio testing, I'm not going to get into the nitty gritty. If you care about this stuff, we're providing the data as an experiment, and we might continue to do so in the future. For this testing, I'm using the Rightmark Audio Analyzer software, which requires you to connect the line out to the line in using a short 3.5mm to 3.5mm high quality audio jack. The OS speakers are set to 100% and the line in is adjusted until the software is happy with the levels. The test looks at a number of things, including noise levels, range, harmonic distortion, and stereo crosstalk, for example. And all of the boards did test quite well. So there you have it. Every single X870/X870E motherboard tested. Well, almost every motherboard. Some have been announced but are still yet to be released. But having tested 20 boards, you should have a pretty good idea of which model is for you. A lot of these boards are very well designed and pack great features, but they're also hideously expensive. There are certainly a number of justifications for why the X870E models cost more. You just need to be in need of those new features for the price to be justifiable. Also, as you get closer in spec with the X670E models, the price gap becomes a lot smaller. The MSI X670E Tomahawk Wi-Fi, for example, costs $250 US, and it only offers a single 20 gigabits per second USB port on the rear and Wi-Fi 6E. Ultimately though, I'm fine with having more options available, but it does seem as though the 600 series boards are now being phased out in favour of these more expensive 800 series boards. Perhaps pricing for the 800 series models will eventually filter down to the same level as the 600 series models they're replacing, but also that could just be wishful thinking. Anyway, I'm sure that we'll have more AM5 motherboard content in the near future, and if you'd like me to produce more of an X870 buying guide where I pick the best models at a few different price points, then let me know in the comment section below and perhaps that is something I can do. For now though, we are done with this one. Happy to be done with this one. It has been a mammoth amount of work. So if you appreciate it and you want more hardware unbox goodness, then consider hitting the join button, or alternatively heading over to Patreon to become a member there. It'll give you access to stuff like our exclusive Discord server, BTS content, monthly live streams, a lot of cool things there. Check it out if you're interested. If not, perfectly fine. And I would like to thank you for watching this video. I'm your host, Steve. See you again next time.